Hello students, this is video 2.7 and the unit title is biconditional statements for this section, and our objective is I can write biconditionals and determine a good definition. The IXL skill is I8, so this is a new IXL skill. I've not written this one down, so please make sure you get it. Alright, let's go flippers. So what we want to do is, again, we want to refer to our statement that we've been working with. That is our conditional statement, if I like chocolate, then I like cake. So here is a new related conditional statement, and it is called the biconditional. And this IFF means if and only if. So it's a shorthand. So if you ever see this anywhere, that's what that means. So a biconditional statement is a single true statement that combines a true conditional and its true converse. So let's actually write a biconditional for our statement that we have now. So the first thing we need to do is write the converse of the statement that we have right now. Here's our converse here. If I like cake, then I like chocolate. So the biconditional is going to be combining both the conditional, which we have here, with this converse. And here it is. So our biconditional statement is, I like chocolate if and only if I like cake. Now we have combined both the conditional and the converse. The logical equivalent for a biconditional statement is literally written like this. P, if and only if, so it's a double arrow, goes both ways, Q, and you read it just like that, P, if and only if Q. The second thing we want to talk about today is the definition. I know in your other classes, especially ELA and global, you write definitions lots of times. So I want to help you understand what a good definition is. A good definition is going to be a statement that can be written as a biconditional and its converse, where both are true and the statement is reversible. So if you can reverse statement, then that is going to represent a really good definition. So let's try it. All right, so here is the conditional statement that we're going to work with, and it is a straight angle measures 180 degrees. So the first thing we need to do is write it as a if-then statement. So this is what I've done here. So the statement now is, if an angle is straight, then it measures 180 degrees. Now I'm going to write the converse, which is if an angle measures 180 degrees, then the angle is a straight angle. Both of these are true statements. So these are true statements. You can now write a biconditional statement, and that's what I've done here. And the biconditional says that an angle is straight if and only if the angle measures 180 degrees. So that's how we do it, and we know that this is a good definition. That's how you base your decision, on the fact that you can write a conditional, write its converse, they both be true, and then combine them into a biconditional. That'll make a good definition. So let's look at a couple of examples here. So example number 1 says, write the converse of the statements below. If they are true, write the biconditionals. So look at A. A says, if a number is divisible by 20, then it's even. Converse is that if a number is even, then it's divisible by 20. Well, let's think of if we can find a counterexample to that first, because I think this statement is actually false. So here's my counterexample. 2. Okay? 2 is even. And if I take 2 and I divide it by 20, I'm not going to get a whole number. I end up getting a fraction, 1 over 10. So that makes this statement false. Its converse is false. The original statement was actually true, but the converse is false. So let's do B. If 2 segments have the same length, then they are congruent. So now let's write the converse. So the converse is if 2 segments are congruent, then they are the same length. Well, this actually is true. So I can now write the biconditional, which will say 2 segments are same length. IFF means if and only if they are congruent. So that is our biconditional statement. Question 2. Write 2 statements that form a biconditional. An angle is a right angle if and only if it measures 90 degrees. Okay, so here are two statements. The first one is going to be our conditional statement. So I'm looking at this biconditional and I'm saying what two statements were used to create the biconditional. And the first one is, if an angle is a right angle, then it measures 90 degrees. The second statement is the converse. Remember, when we take the hypothesis and conclusion and we switch them and we flip them. So this one says, if an angle is 90 degrees, then it is a right angle. These two statements are both true. That's why we were able to write this biconditional. Last question, number 3. If a statement below a good definition. A compass is a geometric tool. In order to test and see if this is a good definition for a compass, we write both the conditional and the converse. So the conditional is simply, if an item is a compass, then it is a geometric tool. And that actually is true. But the converse simply says, if an item is a geometric tool, then it is a compass. This is false, because there are other geometric tools like rulers, like a writing instrument, like a pencil, like protractors, all geometric tools. So this is not a good definition. Here is your secret hot question. It says, what is the biconditional state of the statement below? A hexagon is a 6-sided polygon. What is the biconditional of the statement below? A hexagon is a 6-sided polygon. Remember to work on IXL skill I-8. Have a great night.